Rasulillah, we are still in section 4.3, and we mentioned three properties of the logarithmic function, and we studied how to expand logarithmic expressions. And today, inshallah, we will talk about the other question that can be asked about the properties of logarithmic functions. And this question is condense. They say condense logarithmic expressions. They say condense in the question, or he can say also write as a single logarithm. Write as a single logarithm. So writing as a single logarithm means we will condense, okay? Then we will have, this means that in the question, you will have two logs like this. So if you have addition of two logs, you change the addition into one log with product inside. Two logs with minus between them changes to one log with division inside. If you have p number multiplied by the logarithm from outside, you take it to the power up to the power of m. So you make it log m to the power p. So these are the same properties, but now we are using them in the other direction. Pay attention here that these properties are correct only for m greater than 0 and n greater than 0. This is very important. Of course, because we mentioned that the domain of log, what is the domain of the logarithmic function? The number inside should be positive. So here you have log m, so m must be positive. If it is not positive, I cannot evaluate log m, and n also must be positive. So if you have, for example, len negative 2 times negative 3, len negative 3 times negative 2, okay? You cannot write it len negative 3 plus len negative 2. This is not correct, because len negative 3 is not defined. There is no len negative 2. Len is not defined when the number inside is negative. Okay, so pay attention that we use these properties only if m and n are positive. Okay, how to condense? This is easy. Here you have addition. You change it to multiplication. It would be log 2 times 32, log 64 to the base 4. And this is 3 because 4 to the power 3 is 64. We learned how to evaluate log 64 to the base 4 before. We said we think of the power in which we raise 4 to. So 4 to which power equals 64? This would be the answer. And 4 to the power 3 equals to 64. So log 64 to the base 4 is 3. Okay, here again another example. You have log minus log. So it would be log 4x minus 3 over x. This is condensing or writing as a single logarithm. Write as a single logarithm here. Okay, I have plus. I have len plus len. But I have a problem. I have 2 here, and I have 1 over 3 here. So I cannot use this formula. I cannot use this property, number 1. Look to number 1 carefully. Log m plus log n. There is no number here. There is no coefficient before the log. There is no number before the log. So if there is no number before the log, you can write log m plus log n as log m times n. Now you have 2 here. You have 1 over 3 here. So this is not good. I cannot use the property. So what can I do is to use the last property, the power rule, to write the 2 as a power of x. So this should be your first step. And here also, x plus 5 would be to the power of 1 over 3. And now you have len plus len, and there is no number. The coefficient of len is 1. There is no number before len. It is only 1. So now I can use the product rule and change these 2 lens into 1 len. So I will have x squared times x plus 5 to the power 1 over 3, all of this inside the len. So this is writing as a single logarithm. Same here. I have to write it first, len x plus 6 to the power 4, and I have to write this len x cube, and then now I can use the quotient rule to write it as 1 len. It would be len x plus 6 all to the power 4 over x to the power 3. So it is now written as a single logarithm. Here I have 3 logs, and the question is right as a single logarithm. Okay, I can, the first step, because you have 1 over 4, you have 10, you have to take all of these numbers up using the power rule. So it would be log x to the power 1 over 4 to the base b, but then minus log 5 to the power 2 to the base b, but then minus log y to the power 10 to the base b. And now you can write them as a single logarithm. How? Please pay attention. I can do it in 1 step, and I can do it in more than 1 step. I will show you both. If you do it in 1 step, then you have log b and you have a fraction. Why there is a fraction? Because there is a minus sign, and there is a plus sign. So whenever there is a plus sign, here, for example, log x to the power 1 over 4, this is positive, so x to the power 1 over 4 would be written in the numerator, while 5 to the power 2, which is 25, because there is a minus before the log, I will write it down. And this is y to the power 10 will be also written down because there is a minus before the log. Now, if you cannot understand this, you can do it as follows. The positive, you keep it as it is. And then you take the negative sign as a common factor. So you take minus, open parentheses, and write log 25b plus, because you took the minus as a common factor. So you will have this one. Then you can write it as log x to the power 1 over 4 to the base b minus. Now these 2 logs are added to each other, so we can write them using the product rule as log 25 times y to the power 10 all to the base b. And now you have 2 logarithms with minus between them, so you change them by the quotient rule to division, and you write x to the power 1 over 4 up and 25 y to the power 10 down. So of course this method, the second one, is you should solve like this. I mean, this is the excellent way to solve the question. But if you understand what I said here, you can immediately find the answer, and this will be accepted from you. Okay, so I will always use this method to solve, to get the final answer quickly. So I have 3 lens. First step, I have to take all the numbers up. Now, I have 3 lens, so I will have 1 len. There is a plus and minus, so I will have division. Any plus, I will write it up. So len x cube is positive, so I write it x cube up. Len y5 is positive, so I write y5 up. Product, multiplication between them. And negative len z to the power 6, this means that z to the power 6 is down. Again, this is a shortcut. If you want to do it in steps, you can do it. You can say len. Now these two are positive, so you can start by changing them to by the product rule to len x cube times y5. And now you have two lens with negative between them. So you use quotient rule to write them as len x cube y5 over z to the power 6. So you can use this or this method to get to the correct answer. Here, some examples in the book. Look to the examples. We have A. This is A. The first step, as usual, half, we take it up. Okay, use the power rule. And 4, you take it up. And then you have addition. So you change it to multiplication using the product rule. Part B, you have minus. There is a 3 here. So first you have to use the power rule to take this 3 up, and then you change the subtraction into division as a single logarithm using the quotient rule. Here you have 4, 2, half, 3 logs. First you start by using the power rule to take 4 up, 2 up, half up, and now you take minus as a common factor. So you get these two, and you change the addition into multiplication using the product rule, and then you use the quotient rule and you write the answer. This is okay, and this is okay. If you leave it y to the power half or square root of y, both will be okay. If you want to solve this question as I solved it before, so you can immediately, from this step, you can go to the last one. You have 3 logs, so you write log b fraction x to the power 4 positive, so it's written up. 6 square is negative, so it's written down. Y to the power half negative, so it's written down. So you write it y to the power half or square root of y, and this would be immediately the correct answer. Now, please try to solve these questions by yourself. Notice that the question here is write as a single logarithm. So I think this is easy. You can do it. 53, also 59 is easy, similar to the examples. Also 65, and 67. Let me solve 65. Okay. Half log x5 plus log y5. Half log x5, okay, minus 2 log x plus 1, 5. To the base 5. Okay, what is the question? Write as a single logarithm. Good. What should we do first? Well, you pay attention, you look to the question carefully. Now, this half is multiplied by these two. Okay, so you have two methods. Either you expand, you multiply half times log x and half times log y, or you start by, both are correct, you start by changing these two into multiplication using the product rule. Okay, and you can take this 2 up using the power rule. Now you have to take this half up. So you write it log x, y, all to the power half. Or you write it square root of xy, because the half should be a power of both x and y. Minus log x plus 1 square, 5. And now you have 2 logs subtraction. Subtracted, one of them subtracted from the other one. So using the quotient rule, you change it to 1 logarithm, writing square root of xy in the numerator and x plus 1 to the power 2 in the denominator. So this is 65. 69. Let us solve 69. 69, okay. Log x. 67 is also there. You can try it by yourself, okay. Log x plus log x square minus 1. Log x square minus 1 minus log 7 minus log x plus 1. MashaAllah, we have 4 logs. No problem, don't worry. I can immediately find the answer quickly. As I told you, it would be log, and we will have a fraction. X positive coefficient, I write it up. X square minus 1 positive coefficient, I write it up. 7 negative coefficient, I write it down. X plus 1 negative coefficient, I write it down. This is immediately the answer. If you want to take minus as a common factor from here and you do it step by step, you will get the same answer. Let me solve 67. 1 over 3 times 2 ln x, there is no parenthesis, 2 times ln x plus 5, 1 over 3 times 2 ln x plus 5 minus ln x minus ln x square minus 4. Okay. First, I have 1 over 3 here. Either you leave it to the end or you expand from the beginning. I will always leave it to the end. Okay. This 2, I have to write it up. So it would be ln x plus 5 to the power 2. And ln x, there is nothing to change. And ln x square minus 4, there is nothing to change. Now, I have plus and minus. So I change it to 1 ln with a fraction. So x plus 5 square has a coefficient positive, so I will write it up. X, the coefficient is negative, down. X square minus 4 is also down because there is a minus sign before the ln. Now, what should I do with the 1 over 3? I put it here as a power of all of this. It would be ln. طبعا, if you remember, 1 over 3 here, cube root of, it would be cube root of x plus 5 to the power 2 over x times x square minus 4. This is one way to write the answer. This is the final answer. Okay, we solved, I think, enough problems about condensing or writing as a single logarithm. The final, or the last objective in this section, is using the change of base property. What happens if you want to change the base? Okay, how? For example, the base is b. Here, the base is b, and I need to change the base from b to a. Okay, so the old base is b, and the new base is a. Okay, so how do we change from b to a? We write log mb equals log over log. So it would be log over log. The new base is a, so we write it as a base, up and down. And then we write m up, b down. So we will have log m over log b to the new base, which is a. For example, log 7 to the base 6. Assume I want to change the base from 6 to 2 مثلا. Okay, so the new base would be 2. So I write log with the base 2 up, log with the base 2 down, and then the 7 up and the 6 down. So log 7 6 would be log 7 2 over log 6 base 2. That's the change of base property. In fact, we use the change of base property mostly to change to log 10, the common logarithm, and to log e, the natural logarithm. So if you change it to log 10, this means that log mb would be equal to log m over log b. And log mb would be equal to ln m, which is log m to the base e, ln m over ln b. And this means that, in fact, the button in the calculator, there is a button in the calculator to evaluate log 140 over 5 to the base 5. I mean, there is a button in the calculator to evaluate this, okay? You don't have to use it. You can use the change of base to change this to one of the other buttons, because there is a button for log and there is a button for ln. So you can choose these two. So you can change log 140 to the base 5 to ln 140 over ln 5. Here he said use common logarithms. So you should know what the common logarithms are. For common logarithms, the base is 10. So you write log 140 to the base 5 as log 140 over log 5. Okay. Use common logarithms to write this. So it is log 2506 over log 7. Okay, and you can use the calculator and write the answer. Change of base. Use natural logarithm. Natural. So we change it to ln. So ln m over ln b. So it would be ln 140 over ln 5. Use natural logarithms here. So it would be ln 2506 over ln 7. If you use your calculator, you will get the same answer exactly. So here 3.07 when we used natural logarithm, and here also 3.07 when we used common logarithm. So evaluating log 140 to the base 5 using common or natural logarithms will give you the same answer. Now some exercises. 73, here the questions are use common logarithms or natural. It is up to you, you can choose, and the calculator to evaluate these questions. We need 73, 83, 87. 73, 83, and 87. Well, 73 is using the change of base formula. You can write it ln 87.5 over ln 14. That's easy. Let us see what are these questions about. Practice plus. This is after you finish all the exercises. This is practicing plus, usually somehow a little difficult than the usual exercises. If log 2 to the base e to the base b, log 2 to the base b is a, capital A. So let this equals capital A. And log 3 to the base b, capital C. Write each expression in terms of A and C. Okay, I will leave 83 for you. I will solve 87. I need to write this expression in terms of A and C. And your answer should be, and for example, log square root of 2 over 27 to the base b is A plus 2C, for example. Okay, this is what he meant when he says write it in terms of A and C. So let us try to solve 87. Log 2 over 27. 87 log square root of 2 over 27. What are the information? Log 2 is A, so I know that log 2 is A, and log 3 is C. This is the information given in the question. Log 3 is C. Good. Now, how can I write this expression in terms of A and C? I need to write it in terms of log 2 and log 3. If you write log square root of 2 over 27 in terms of log 2 and log 3, you will write it in terms of A and C. So first thing, this square root, I need to get rid of it. So I will write it as 2 over 27 all to the power half. And now I can take half outside using the power rule. Okay, and now I can write log 2 over 27 using the quotient rule as log 2 minus log 27 using the quotient rule. I need to write it in terms of log 2 and log 3. I have log 2. That's nice. Yani I can replace log 2 now by capital A. But I don't have log 3. So I have to do something here. Okay, what can I do? I can write it half A plus minus. I can write 27 as 3 to the power 3. You should know that. 27, 3 to the power 3. And now what can you do? You can take 3 outside using the power rule. And now log 3 to the base B can be written as C. So the final answer would be half A minus 3C, or if you want to write it, A over 2 minus 3 over 2C. This is the answer of the question. We wrote this expression in terms of A and C. Some more questions here. 95. The questions here, determine whether each equation is true or false. Just tell me, is it true or false? Let us check 95, true or false. This is plus. So we change addition to multiplication. So we write it len 5x times 1. So this is correct. True. There is no problem with 95. 99. Log division equals log x minus 1 minus log x squared plus 4. He used the quotient rule, so this is correct. There is no problem with it. That's exactly the quotient rule. Okay. So 95 and 99. Let us see if some of them are not correct. مثلا 89 is not correct. This is not correct. This is false. Because len E is not 0. Len E is 1. This is also not correct. This is false. Because len 0 is not defined. Okay. You can check. مثلا 95, 94. 94 is false. It's not correct. Because len x plus 1, you cannot write it len x plus len 1. This is not the product rule. This is not correct. Not accepted. Okay. Here also, 96, this is false. You cannot write 3x as x plus 2x and then you write it len x plus. This is not correct. This is not the product rule. If you use the product rule, it would be len 3 plus len x. But it's not going to be len x plus len 2x. So this is false. So some of these questions are correct and some of them are false. I leave this exercise for you. This example, you can solve it as I solved it in the example. I stop here. This is the end of section 4.3. And inshallah, tomorrow we will start the next